OCR Statistics, Discrete Random Variables 1, Mean and Variance. This is video 1.2 on the mean and variance of a discrete probability distribution. Because we're now going to look at averages and spread of discrete random variables, it's worth looking back to see what we did at GCSE. So this kind of question should be very familiar to you. We're being asked to work out the mean of a group of 20 marks in a test. So whenever you did this at GCSE, you were probably asked to calculate it both by hand and then possibly just by inputting the values into a calculator. If you did it by hand, you would have added an extra column, and in this case it would have been the frequency times the mark. You would have calculated all these values and found the sum of f of x. In this case, it's 142. Then you would have also found the sum of the frequencies, which is here. And we could write this as the sum of f, or we could also write this as n. And then what you did is you divided 142 by 20, and the formula would have looked like this. So remember, x bar is just the mean, and this is the sum of f of x divided by the sum of the frequencies, or n. And this gives us a mean of 7.1 in this case. Now we're in further maths. What you need to know is how to find what we call the expected value of the random variable. And this is the most commonly used measure of average. So it's the expected value or the expectation. So we're now going to look at how to calculate this whenever we've got a random variable. So the expectation of a random variable is the mean of the random variable, basically. So it's if we measure the random variable an infinite number of times, this is the value that we would expect to get. So just to remind you, this is the formula that we just looked at whenever we looked at a table, and this is the mean. We can write this formula in a slightly different way, which you can see here. Remember that f over n is what we call the relative frequency. You may remember, if you didn't know the probability of something happening, then you could do an experiment to try and calculate this. So say, for example, you were trying to work out what the probability was of rolling a 6 on a biased dice. You may have rolled it 200 times, and the number of 6s you got would have given you what we call the relative frequency. Now let's look at the formula for the expected value of a random variable. Notice how these two formulas look incredibly similar. So in order to find the expected value when we've got a probability distribution, is that we multiply the individual value of the random variable by its probability, and then we add it up. So notice how similar that is to what we've just done in the table. Another way of writing expectation is mu, so you could see it in that form, and these are given to you in the formula booklet. So this is another form, but it means exactly the same thing. It's just saying that the probability that the random variable is equal to that value. As well as knowing the average of a random variable, essentially, we also want to know how spread out it is. So this is something that variance will tell us. So you should have seen these formula before, and this is just when you've got a set of data. You can use any of these formula to find out what the variance is. Again, notice here we have relative frequency. Whenever we've got a discrete random variable, this is the formula for variance. So again, notice how similar these two are. Okay, the first part of the formula looks very similar, and also don't forget here that this is just another way of saying the expected value of the random variable, or the average of the random variable. This is another form of the variance, the formula for the variance. This is the easiest form to remember. And what we say is that the variance is given by the expected value of x squared minus the square of the expected value. So just to summarize, we have these two main formula, and these will help you to calculate the expected value of the random variable, and it'll also tell you the variance, which indicates how spread out our probability distribution is. We're now going to look at an example, and in this case we've got our random variable capital X, and it can take the values 1, 2, 3 or 4. This should be familiar to you if you have watched video 1.1, and in that video we showed how to do part A. So it turns out that K is equal to 1 over 30. So we worked out that K was 1 over 30, and we were able to work out the probability distribution of this random variable, which is shown in this table here. What we're going to do now is part B, wherever we're going to find the expected value of X, and then we're also going to find the variance. So first of all, to find the expected value of X, we're going to use this formula, which is telling us that we need to multiply the value of the random variable by its probability and add them all up. So whenever we've got our probability distribution in a table, the easiest thing to do is add another row and put XP in that row. So the first one would just be 1 times 2 over 30, which is 2 over 30. And the second one would be 2 times 4 over 30, which is 8 over 30. And then in the same way we would get 24 over 30 for 3, and we would get 64 over 30 for 4. So all we need to do now to find the expected value is to add these all up. So we have 2 over 30 plus 8 over 30, 24 over 30 and 64 over 30. So when we add all those up, we're going to get 98 over 30, which we could simplify to 49 over 15 or change into 3.27 to 3 significant figures. Just like it's perfectly fine to have a mean, which is not an integer, so you may have heard people say 2.4 children, for example. It's perfectly fine to have the same with expectation. So even though these values up here are discrete, so these are discrete values, our expected value can be a decimal. Whenever you get your answer, it's always really, really useful to look back and to think, does it make sense? So our values are anything between 1 and 4, and our expected value has come out as 3.27, which is a good start because we know that it has to lie in between those. And also look here that the probability of getting a 3 and the probability of getting a 4 are higher than the probabilities of getting 1 and a 2. So it does make sense that our expected value is lying in between 3 and 4. Part C is asking us to find the variance of X, and the easiest formula to use is the one that I asked you to learn. So remember how we say this is the expectation of the square of X subtract the square of the expectation. So we've already worked out what this is because we just did this in part B. So we already know this. This is the bit that we must calculate first of all in order to find the variance. So again, what we're going to do is we're going to add another row, and this row is x squared multiplied by the probability. So in the first one it would be 1 squared multiplied by 2 over 30, which is just 2 over 30. And then we would have 2 squared multiplied by 4 over 30. So that's 4 times 4 over 30, which is 16 over 30. And then 3 squared times by 8 over 30. which would be 72 over 30. And then finally we have 4 squared times by 16 over 30, which is equal to 256 over 30. So here's that section of the table written out neatly. In order to find the expected value of x squared, we need to sum all of these values together. That's what this part is here, represented here. This is the expected value of x squared. And remember, this was just our expected value that we got in part B. So we calculate this and we end up with a variance of 0.862, just 3 significant figures. This was 1.2 mean and variance of a discrete probability distribution. And the next video is 1.3 linear combinations of random variables.